Of equations. A system of equations is, again, if you just look at two or more equations, for us, we're going to restrict it to two equations that have two unknowns. In grade 8, you looked at one equation with one unknown. One equation, one unknown, one variable, right? Like 3x plus 2 equals 8, something like that, and you had to solve for x. Your solution looked like, what is x equal to? Grade 9, you continued with that, but you made the equations look really complicated. So you didn't just have something like this. You had 2x minus 5 plus 4x equals 7x minus 2 or something like that. But it still was the same idea, x equals something. Okay, that was what your solution looked like. So you still had one, you were looking at a single equation at a time with one unknown. Then you went to grade 10, and you started looking at equations that didn't just have one variable, they had two variables, and something like 2x plus 3. As soon as you have two variables, there isn't just one single thing you can have as a solution. So what you started to do, and maybe you didn't realize or maybe you didn't make the connection, is you started to draw a graph for this. You never drew graphs for these equations because they wouldn't be very exciting graphs. If the solution to this is 2, if you really had to graph that, here's a number line. You only need a one-dimensional thing because there's only one variable. And there's the solution, 2, right? It's a dot. It's a one-dimensional graph because you only have one variable. As soon as you were in grade 10, you needed to draw two-dimensional graphs because you had two variables. So when you draw a graph for that thing, if you say that 2x plus 3 looks something like this, it's a line going up there, this is 3, and has a slope of 2, what you're really showing in grade 10 there is you're saying all of these points everywhere on that line is just an infinite number of points that are all solutions to this. Okay? If you don't lose sight of what a graph is. Let's put in that one I was just talking about here. A graph is just, when you draw that graph for that line, y equals 2x plus 3. Okay, there's that line. Let's even be exciting and make it a different color. Does anybody care? Is that good enough? Make it what? Pink, like this? This night, how about that one? Is that good? Now that we've really gotten into this, let's actually make it so you can see it too, because I think it's pretty skinny there. So that's that equation. Okay, that's this equation here. Anywhere on that line is a pair of numbers like that. Okay, now this doesn't show what that pair of numbers is. We can make it show what that pair of numbers is. What is that pair of numbers? Now that point's not pink, but -1, 1. If you put that pair of numbers in that equation, it works. You can click on a lot of other ones here, right? And I'm not going to make it show all the other ones here. But there's lots of points there. Those are all those points up here. All those pairs of numbers work in this equation. They satisfy that equation. If we go up here, you can continue along here, right? Now, really, I could do this one too. Anywhere on that line, even though these are not such nice numbers, they still work in that equation. Everywhere you go here, right? This is anywhere you put a point on this line. A line is just really, it's not going to let me put too many, but anywhere you put a point on this line, that's a pair of numbers that works in that equation. I could put an infinite number of these all over, and I'm sure you'd be excited to watch that. But the line is meant to represent all of these points. It shows every single point. Well, it's saying all the points on that line work in that equation. If I put another equation in here, somebody want to make one up here? Y equals what? How about negative something? Negative 0.5 x, I don't know, minus 1, something like that. Okay, there's another equation right there. If I put points on that line, the points on that line are all points that work in that equation, right? Again, that's what a line is. It's showing all the points that work in that equation. what we're doing with systems of equations here is we're looking for points that work in both equations. Where do I find that on here? Where's a point that works in both equations? If all the points on this line work for that equation and all the points on this line work for that equation, how many points are there that work in both? How many are there? Don't all speak at once, I can't hear you. 1. And where is it? Where they meet, right? Like there, okay? Now I know that maybe seems more obvious than not, but just keep that in mind for this whole unit. You're using, if you have only a single equation in grade 10, you just use one equation, right? So we're back to this. In grade 10, you looked at one equation that had two variables. There was no answer. You couldn't say solve this, right? This thing. You can't solve it because it's got an infinite number of points that work, right? If you have one equation with two variables, you have an infinite number of points or whatever, right? Infinite number of solutions or points. Or points. What we're doing in grade 11 is we're now changing to, or we're looking at systems. A system is when you look at more than one equation or enough equations that you have variables. If you have two variables, you need two equations. We could look at three variables, three equations, but we're going to limit it to this. If we have the ones that I just had there, 2x plus 3 and y equals, what was the other one? Negative 0.5x minus 1. If you graph both of those together, there's only 1 point that works for both. 1 point. I mean, works is not a very mathematically correct word, but works for both. That's what the solution is. For the ones I gave you last time, we started by how were we looking for solutions right off the bat? What was the first way we did? I think I gave you something like x plus 6 and y equals 4x, and we said we're going to find the solution for that. What was our first method that we learned to solve that? Okay, to solve that, what did we do first to try and solve this system here? Make a table for each one. So either make a table like that for each one, or in the calculator we said this. You did y1, y2, right? So you can make two separate tables or not. I think as a starting point that's good because it has the advantage of you see what you're doing, right? When you're making a table, basically what you're doing is we go back to this. You're writing down all these points that you can think of and all of these points, and then you're trying to find the one that matches like that. Now the first one I gave you, these are simple enough numbers that probably you're going to stumble on the right one just by trying things. 0 for this one, y equals x plus 6. 0 is 6 and 1 is 7 and 2 is 8 and 3 is 9. And then if you try the other one, y equals 4 times x. 0 is 0, 1 is 4, 2 is 8, 3 is 12. So just by trying things out, we stumble on the solution. That's not always going to work. It's a way of doing it, but it's not a very efficient way of doing it because really what you're doing then is just trial and error. If you go to this, we'd be pretty unlikely to come up with a solution for that by trial and error because if you look at that point there, it's showing it, where is it? Which one is that? This one down here, I'm assuming. J1, that point. Negative 1.6, negative 0.2. You're pretty unlikely to try those numbers. So the next method we're going to look at is by graphing. If you either graph something by hand or graph it with some software or a calculator, you can find the intersection pretty easily. So that's method 2. That's what B2 is. Using a table or tables, that's what we did in B1. Method number 2 is going to be graphing. You kind of have to know how to do things two different ways here. Graphing by hand and graphing using technology, either calculator or that software. That's what's in B2. That's what we're going to do, okay? That's what I would like you to work on right now.